to you. So, good afternoon, everybody, and welcome to today's webcast from Range 4, where we're covering defect control and testing uncovered. My name is Paul Hancock, and today we're joined by Stuart Feasey from IBM. We'll be looking at how using IBM's test automation solutions can deliver value in the following areas: reduction in the cost of defects, avoidance of test and development environment expenses, reduction in spend on third-party consulting and testing fees, reduction in the time spent on testing, and the elimination of bottlenecks within the development lifecycle. I'd like to hand over to you, Stuart, now.
Okay, thanks, Paul. Thanks, Paul. So Ranger 4 have invited IBM to speak about IBM's testing solutions. Middleware testing is the main focus of today's discussions. I used to work for a small company called Green Hat. Green Hat was acquired by IBM just over 2 years ago. Green Hat have been in this space for over 10 years, building middleware-focused testing solutions that integrate directly with middleware transport protocols. It's a bit different from most testing solutions in that it doesn't rely on any kind of user interface or GUI-based product to drive data in and validate responses. So what's driving this sort of desire that people have nowadays for improved testing? So of course we've got increased costs of quality. What we're seeing, typically people used to outsource a lot of testing. Manual testing would be undertaken in remote, lower cost geographies, but we're seeing wage rates increase in these geographies by between 10 and 15% year on year. We're also seeing increasingly complex environments. So the kind of environments that we're typically talking about involve several legacy components. Those legacy components are often quite difficult to change in any way. They don't typically get refactored or redelivered. They're just left there because they've worked for a number of years. And of course, adding new capability typically means bolting things onto those, which of course results in more components to test. You have more touch points in your testing suites, scenarios, etc., to ensure that the system is behaving the way it should, which of course means that these environments get bigger and bigger and harder to test. We've also got this problem of balancing quality with speed. So typically developers and testers can spend up to 50% of their daily time just maintaining these complex environments. So of course anything we can do to address these three primary issues is going to help here. And that's the idea of the Green Hat acquired software. It's no longer called Green Hat. All the names have been changed or blue-washed. Now the key component is what's called Rational Integration Tester. However, most people still refer to it as Green Hat. The name has stuck, so often we'll just use the name Green Hat interchangeably with the IBM names, and I do apologize for any confusion that may cause. So what we're looking at the moment in the current slide is a complex middleware environment, an environment comprised of several different components with a federated enterprise service bus in the middle. So messages are traversing this environment, touching on various service components within the environment before delivering downstream interactions, etc. So we've got multiple layers of technology in here. Typically these components may not have been designed to actually work together in a cohesive manner. Typically testing any one of these components in concert with the other pieces presents a bit of a challenge because we need a test tool that understands the interactions and can actually place rules on how these interactions happen and whether they're happening in an appropriate fashion. So the technology we offer obviously has a number of different capabilities in there. Different vendor capabilities are catered for, and I have a more in-depth slide which I'll show in a second, which shows exactly the kinds of things I'm talking about. We've also got, typically a test environment is going to be accessed by several teams. Now in this particular instance we've got 3 different stakeholders here. Each one of these is going to have different needs from the test environment, and if any one of them decides to change the functionality of a particular component, that could have knock-on effects for the remaining 2 stakeholders. We offer a service virtualization capability, which you can think of as stubbing on steroids, essentially. It's a more cohesive way of stubbing out these components to allow people to access behavior that they're accustomed with in a test environment that could be virtualized, essentially. So, for example, if the finance department choose to change a particular component within this environment, they could build a stub which mimics the behavior of the environment as is, or that component as is, run that in the environment so the other 2 stakeholders are unaffected, whilst they go away and actually change the behavior of this. And we can cater for multiple instances of stubs in the same environment whilst their live counterpart services are running. And we do that through a technology called system PassThrough, which I'm actually going to show in a brief product demonstration at the end of this session. But the key message is we can run a stub at the same time in the same place as the real service component, and the way we differentiate the messages that the stub should deal with as opposed to the live system is through content-based routing, essentially, and I'll show you exactly how that works a bit later on. So typically people look at testing their middleware infrastructure through GUI-based interactions. So what we're seeing here is an iceberg slide with the GUI, or the user interface, represented at the top below, above the waterline. Of course, there's an absolute wealth of information that's available below the waterline in the middleware tier, where these messages are being sent backwards and forwards on queues, HTTP transports, etc. Now, Green Hat interacts below the waterline. It has absolutely no dependency on a user interface for its interaction, which means you can actually test the middleware components at the same time as you're developing the front-end components, and kind of divorce yourself from this dependency on having a stable user interface early on in your testing. Now, if we look at a typical testing scenario driven by the user interface, typically I'd enter some data in and I'd click a submit button or a proceed button or something. That would result in back-end services being accessed, data being collated, pulled back from databases, before ultimately giving a response back to that user interface. And in this case, everything's absolutely fine. Perfectly successful test case, no errors to sort of look into, so we can move on to our next test case. Now, the problems typically occur with this approach when there are problems in the middleware back-end. The error messages you typically get back at the user interface are not particularly descriptive. And often if a user encounters an error during testing, they'll go to the infrastructure team and ask to sort of try and recreate the problem, maybe have a look in some logs to try and work out exactly which component in the back end failed. In this instance, it's a database access routine that would probably have resulted in something like a JDBC timeout error back in the user interface. Now, where Green Hat is different is that it places validation points on all the important areas in the back end. So we're monitoring the payload as it goes through the back end systems, and we're sort of ticking each one off. As the components are accessed, we make sure that the responses they've given are in line with expectations. Of course, when something goes wrong, we can detail all of that information to the end user if they're running the test in real time through our GUI-based product, or we can output that data to a report if this test has been driven by some sort of continuous integration, continuous delivery type solution. So very clear access to the error messaging, full error trace information is given to allow developers to get to the issue and fix the issue quickly and resubmit code for test in the next cycle. So just to recap, we've divorced ourselves from the user interface. Here, Rational Integration Tester, the GUI-based component of our product set, is injecting a payload into the system under test and consuming the output that comes back as a response message. We can do more than that. We can browse and validate any database tables that would have been affected by this data injection, make sure that the data has ended up in the tables in the correct formats, etc. We can also browse and validate any interactions between the systems or the individual components that make up the system under test. And likewise, we can do the same thing with third-party business partner interactions and ensure those things are behaving the way we expect them to. And this leads me on to our Stubbing solution. And I've kind of touched upon this already with service virtualization. We use the terms service virtualization and stubbing interchangeably. But essentially what we're looking at are the reasons why test teams typically sit twiddling their thumbs waiting for something to happen in an environment. And of course anything we can do to address this, because we are talking about the entire team sitting typically, anything we can do to make testing possible in an environment, even though all the components aren't stood up, is obviously going to be of massive benefit. This could be something as simple as a third-party business partner message feed that incurs a cost each time you hit it. For example, it would be useful to divorce ourselves from that in our sort of lower down the development lifecycle, development and test environments. You know, we're typically not testing business partner interactions. We're just depending on them to have an end-to-end test scenario. So same kind of slide here with the iceberg in the background, but this time I've built an environment which is comprised predominantly of virtualized services. So I'm only interested in testing 3 components here. So I've got 3 validation rules set up against those when I inject data in. Everything else in this environment is essentially virtualized. So no hardware minimal hardware footprint, I should say, because you're going to have to run these stubs in our virtualization server. But no licensing costs associated with the proprietary technologies. Obviously, you're running everything through the virtualization server. It's a much smaller footprint and much easier to manage. We spoke earlier about how up to 50% of a developer or tester's time can be spent managing just the environment on its own. Running virtual services goes a long way to addressing that time spent. It's typically much easier to maintain and run virtualized instances of things than the real components. So where does Rational Integration Tester fit within a typical quality management type of testing environment? Well, as most of these quality management tools cannot speak directly to the system under test, we kind of provide a man-in-the-middle capability. So we have hooks into all the major quality management tools from HP and IBM. And we also obviously have hooked into the system under test through our message interfacing technology. We've also got the ability to plug other tools in to Rational Integration Tester, such as defect management tools, source control tooling, etc., continuous integration solutions. This is something we're seeing more and more. People will run their overnight, or well, not even overnight anymore. Several customers build a solution throughout the day, deploy that solution several times a day, and it's really useful if you can run an automated regression test as the end piece in that cycle, and we can plug Rational Integration Tester in through its ANT interface to facilitate that kind of interaction. So just to recap on service virtualization here, we have a system under test which has an external third-party business partner dependency. The first step in this process is to access the third-party business partner feed. Without that in the environment, the test can't really proceed unless we do something clever to work around this. But with our stubbing technology, there's no need to sort of corrupt the system under test by pointing it in a different fashion at something or changing the way the system works to avoid this interaction, you simply run a stub. The stub sits there on exactly the same middleware protocol, expecting exactly the same kinds of messages, and responds in exactly the same kinds of ways that that third-party business feed would. So what we're aiming to do is avoid changes to the system under test, to actually allow you to run a stub as though it really were the real test feed from the business partner. So I mentioned supported technologies. This is it's not an exhaustive list, but this is the main things that we typically see customers using the tool against. Things like HTTP web services, obviously fully covered. RESTful interfaces, that's something that's becoming more predominant with mobile communications, JSON interactions, etc. But we've also got more proprietary capabilities in the tools, things like mainframe interactions, KICS and IMS, two fairly old mainframe technologies, but very, very predominant in most large organizations. So we can interact with those things, we can drive data in, and we can virtualize the way they behave, which is a massive cost saving in many ways. If you don't have to stand up the full mainframe capability in an environment, that's obviously a massive headache removed. Other technologies here, WebSphere MQ, obviously IBM's leading middleware integration platform that's fully catered for, as well as things like TIBCO, software AGs, web methods, etc. SAP, that's something we've recently built a very strong capability around. Message formatters. Typically, we see a lot of testers not necessarily coming from a coding background. They're not necessarily familiar with all the various formats that a message can take. And sometimes creating test data can be a little bit onerous. The tool aims to address this by offering built-in message formatters for all the common message types. So obviously things like XML are fully covered, but more sort of awkward interactions through things like Swift gateways can be harder to understand. They don't typically contain much contextual information, but the tool gives those messages context by essentially displaying the fields within the message with a message field label next to them, so you know exactly what the application ID field is, for example, even though the message in its raw format would give you very few clues. So all of that's built into the tool. So just to discuss how people typically go through the software development lifecycle, where defects tend to be discovered, etc. What we see a lot of our customers doing prior to adopting the Green Hat technology is going very quickly from requirements gathering into writing individual units of code and unit testing those individual components. Now, when developers are writing code, often they find deficiencies with the requirements. Maybe the requirements aren't particularly accurate. They may have to make some changes to the way things were initially defined, and perhaps the requirements don't get updated as all of this is happening, or at least not in a timely fashion. So of course, when all of the individual developers we've got writing code look to bring their code together in some sort of shared environment, we can see disparities, we can see mismatches between what these interfaces expect the message to look like, essentially, which results in this big bang scenario. We bring all the code together in a systems integration testing environment. Often the components don't marry up, and we spend an awfully long time in system testing. Not necessarily testing. What we're doing is trying to plug the system together in a coherent fashion so that we can begin testing. Performance testing typically gets left until quite late in this cycle, because we can't performance test something that doesn't hang together in a coherent fashion, which puts us under pressure as we try and get into user acceptance testing, and ultimately we proceed into operational acceptance testing. So This big bang scenario produces multiple problems hitting us all at the same time. Lots of risk because we don't really know how long it might take to fix the system testing environment. And of course it can work out to be quite expensive. So how do we propose doing things differently? The tool goes some way to addressing requirements-based problems by giving us a way of abstracting the requirements away from our test sequences. So what I mean by that is we can build an abstraction of what a message interface looks like and then build tests and stubs that are based on that abstraction, so that if the interface changes on a regular basis, we just update that one requirements artifact and the changes propagate through to any associated or linked tests and stubs. The area that we see most benefit with, however, is running stubbed interfaces or stubbed versions of the code that the individual developers are writing. So if I imagine I'm a developer, if I take the requirements, which give me an input and output message schema or structure, I would build a stub before I've written a line of code and stand up a very simple hard-coded interaction. So anybody can access my stub in a shared environment, and they can effectively code against it. If they call out to my service component that I'm building, they'll get a response back from the stub, and they'll know immediately whether their message meets the requirements of my stub, because they'll get an error back if it doesn't. So essentially I get this embodiment of the requirements in the environment before any code has even been delivered. So I'm effectively integration testing before we've even got any services stood up. I'm integration testing against the stubs, which means that when we actually come to integrate our code with our colleagues, what we actually get is no big bang. We get very few problems because the interfaces have already married up and they're perfectly in sync, because the stub, if it needed to change, has been reconfigured, redeployed. So each time I've changed this interface along the way, everybody in the environment would have been aware of it. So everything is compressed. And we can also begin performance testing much earlier in the cycle as well, because that stub that I've built, I can associate non-functional behavior with it and code it to respond in a time frame that I dictate is acceptable, which is obviously governed by the non-functional requirements of the system. So we've got accelerated testing. We've reduced this cycle. We've also reduced costs, but most importantly, we've lowered risk by giving this sort of embodiment of the requirements at all times in the environment, so we know exactly what we're coding against. Few points about the virtualization capability. Absolutely no need to modify any of the application code to run a stub. All that's usually required is to point the client endpoint, so usually we're talking about client-server type interactions. Any client connections would go via one of our proxies or intercept technologies. So it's still the same ultimate endpoint, just goes via one of our proxies, so we have full visibility of what's going on. We get to see all the messages going through the environment, and that gives us that dynamic capability to step in and do content-based filtering and routing if need be when we're running stubs. I'm not going to dwell too much on these points because I want to get into the demo and actually show you the software, because I found when people see the software, that's really when they begin to appreciate quite how easy all of this is. So we've seen this slide. There are essentially three components to the Green Hat product set. There's a GUI-based component, which is referred to here as Rational Test Workbench. That's essentially where developers and testers sit and write their code, write their tests, write their stubs. If, for example, a tester finds a particular stub they built to be of use to other people in the environment, they can deploy it out to the virtualization server and give a long-running stubbing capability. So we can actually stub out interactions with system components on a long-term basis. We also have a performance test component which allows us to inject load into the system under test. And the really neat thing about that is we can reuse any functional tests that we've already built through our GUI-based component. We can simply add some metrics capturing actions to those existing tests and turn them into performance tests. So there's no need to write a whole separate bunch of performance tests when we get to that particular issue. This is an interesting case study. This is a customer that did a case study for us over a 2-year period where they adopted the tool. And essentially what we're seeing here, the average cost of a project is the blue bar. You see in the initial phases that was quite high at 160,000. And the number of projects completed year on year, which is the green bar, started off at 110. By the end of the 2-year cycle, that had practically doubled to 205, despite the fact that the cost of these projects was always going down. And the main reason for that was they were reusing tests and stubs that they'd already built, that they built further down, in the 2010 era. They could still make use of those things in 2012 and embellish them, obviously, for any new functionality. So the demo. Now I want to just show you quite how simple it is to create a stub, because often people hear a lot of these technical terms and they think, oh, this sounds very difficult, very complicated, etc. And I'm going to show you just how simple it is. What we have is a demo-based hotel booking system. So this is a very simple application. Essentially allows me to input some test data to book a flight. I get a response back from the system under test. So this is essentially the key components of this architecture. So we've got the web page, the GUI. Behind that we have a WebSphere MQ queue manager. Behind that is a WebSphere application server. And at the ultimate end is a database. And all the database does is increment the issued reservation number by 1 and send a message back to the GUI. So it's a very simple application, but it gives us a really clear way of demonstrating how the tools can work with these technologies. Now, if we examine the scenario where we need a new test environment, we need a new development environment, but we don't have licenses for an application server or a database server. Now, typically that's going to result in a broken environment that's not of much use, but of course we can use our stubbing capability to mimic the behavior of both the database and the application server to give responses back through the queue manager to the GUI, and we're going to see this in the demonstration. We're also going to see a demonstration of what I've referred to as sift and pass-through capability. Sift and pass-through capability gives us a way of doing content-based routing on the message fields within a payload. So here we're looking at payment types, and only MasterCard has been filtered by the stub. All the other interactions on other credit cards, they go through to the live system components. So what we're doing here in the stub is looking at that field, deciding based upon the rules of the stub whether the stub should provide a response. If the stub is not interested in that particular payment type, we'll simply place a message back on the queue and allow the live service to pick up the message and deal with it as it would normally. So, just step into my demo environment. So this is our holiday booking application that we've mocked up. I've already entered some data here in the booking fields, about my name and payment type, etc. And we'll see when I click this proceed button, what we get back in the GUI is a reservation number. And if I do this again, we'll see that reservation number increments each time I click that proceed button. So we're at 15 at the moment. So this is Rational Integration Tester. It's a GUI-based component of Rational Test Workbench. And here we have a basic mock-up of this system under test. So within the middleware tier, we have a make booking operation, which is what's listening essentially for interactions from that GUI. We receive a message in the make booking operation, process via a sub-process based on the payment type. We can see here that we have a WebSphere MQ queue manager, which is forming a dependency based on the middleware integration technology. We also got the bookings database represented here. And if I double click on the make booking operation, you can see that we've got some message schemas attached to that. Of course, I can modify these if I want to change the way this behaves, and the underlying queues within the WebSphere MQ queue manager, which is the message transport in use here. So without dwelling too much, what I'm going to do is just record what goes on within this make booking operation, and we'll see how quickly we can turn that into a stub and how quickly we can turn that stub into a system pass-through based stub. So we're starting off in the architecture perspective of the tool. We're going to jump through several different perspectives during the workflow here, and I'll point out when we hit each one. But for now, I'll just record or add an event monitor based on the make booking operation. I'm given the option here of recording at a finer level of granular detail the things that go on in the dependencies that we've defined within the logical model. For now, I'm just going to record at the top level just to see what's going on with make booking. So I start recording in the recording studio perspective of the tool, which we automatically jumped through to when we hit that add event monitor button. And we can see now recording is in progress. If I step back to the GUI and I resubmit my booking details, we'll see we get a reservation number back of 16 this time. Back in Rational Integration Tester, we've actually captured these two messages as they went through the queue manager. So I've got all the data I entered when I booked my flight and the response that came back with a hard-coded value of 16. I'm going to highlight both of those messages and just click the save icon. For now, I'm just going to save this as a stub, and I'm going to save it with hard-coded values instead of storing the data in a spreadsheet or a data model behind the scenes. So we have ways of managing test data, for example, that make things a bit less onerous when it comes to updating that data. And I'll just step through to the summary here and give my stub a name. And this will push me through to test factory perspective, which is essentially where I would embellish my stub if I chose to. Rules of the filtering, so we can see by default filters have been applied for each and every one of the fields in this message. So this is a fairly restrictive stub. It's only at the moment interested in payloads which exactly mirror what we initially recorded. So of course I can switch these things off. So if I highlight the entire message contents, I can change those filters to remove equality checking. So it's gone from being very restrictive to incredibly permissive. Now it's interested in everything that comes through on that particular operation. If I save my stub, I can run it just by clicking one button. This will run in the test lab perspective where we view the output of our tests and stubs. So now, if I go back to the user interface and submit the same payload, what I see is that number has stopped incrementing. And I haven't had to switch off the live service component. That's still running there in the background. It's the rules within the stub that dictate where this message gets dealt with. And essentially that's based on the filters that we set up within the stub. So at the moment, this is set up to deal with everything that it sees. If I change the filter on this stub to put a filter in for Maestro, so I just reactivate that, check for equality against Maestro, save my stub, and the tool's noticed it's already running, so it's offering to restart it, which is fine. So we get pushed back into test lab perspective. Now what we'll see, when I query the system for a booking based on visa payment, I get responses back from a live system component. Same thing when I do American Express. That number keeps incrementing. I go back to Maestro. What we'll see is that value is stuck at 16. And if we're in any doubt at all as to whether that is somehow some sort of smoke and mirrors thing, what I'm going to do is change the output from that hard-coded value of 16 to actually use a date timestamp based on the host operating system. There we go. Let's save that stub and rerun it. And now, again, for visa, just prove that. That keeps incrementing. To Maestro now, we should get the current date timestamp. There we go. And that will change each time I hit the start. So just wanted to show, I know we've got limited time today, but I just wanted to show how easy this tool is to use. Once it's set up and configured in the environment, it really is very easy and very empowering for testers who aren't necessarily even from a technical background to create stubs, to run tests, run those stubs up. We're really aiming to make life as easy as possible for these people. So if there are any questions, I'd be happy to answer them now.
Hi Stuart, it's Paul. We do have 3 questions which have come through from today's attendees. So the first one is, what are the main financial benefits organisations see from adopting the Rational Green Hat products? So,
I mean, I mentioned third-party business partner message feeds earlier. That can be absolutely huge in and of itself. Typically, banks have a number of interactions with gateways of a financial nature, and they need to stand those up in every single one of their environments, even if they're not particularly interested in what comes back from them from a testing perspective. It forms part of the enterprise architecture, and it needs to be in the environment to facilitate an end-to-end test. So we can run stubs in those environments and remove that expense. I mean, it's typically anything up to about 5p per message that people are incurring. So that's one big benefit. Of course, being able to do end-to-end testing earlier on in the cycle and finding testing-related issues much earlier, that can be huge as well. So shifting everything to the left, allowing people to discover defects much earlier on. As with the title of this whole session, what we're aiming to do is find defects before they become major defects, big defects that are difficult to unpick. If we can find them early on in the dev and test environments, they're much cheaper to fix and have much less of an impact on the project.
Excellent, thank you Stuart, thanks for that. The second question is, how would we get started?
Okay, so we offer quick start packages for the technology. We recognize, even though we do try and make it as easy as possible for people to adopt the technology by providing wizard-based interactions, etc., can be a major jump to the way people do their testing. It's a real paradigm shift. So we have a services department which we can engage very quickly to come in and actually help set up the software, install the software, configure your first services, give mentoring, etc. We also have training classes and free training resources which are available on the internet for everybody to access. So there's lots of help there to get up and running quickly.
Great, thanks. And the final one is, I think you may have mentioned this, but the question is, do you support proof of concepts? Maybe I know the answer is yes, but maybe it might be worth just sort of setting out a little bit more about what typically the steps you take in a proof of concept.
Okay, so once a customer's identified a real need for the software, and we typically sit with them and work out what the return on investment they're planning to achieve with the software is, and we can advise whether that's attainable or not. If the customer wants to see the software running in their own live environment, we typically come in and do a proof of concept, as Paul has suggested. That typically ranges from between 3 and 5 days in length. Try and define as much of the content of that proof of concept as possible before we arrive on site. We have unfortunately gone into customer sites where the customer's environment really wasn't ready for us, and it just results in a lot of wasted time for everybody. So we're more than happy to do proof of concepts, absolutely. But yes, obviously a bit of planning beforehand.
Excellent, thanks Stuart. I'm just double checking that no last minute questions have come through. Don't think they have. I think that's all of them. So thank you, Stuart. Thanks for today. It's really interesting. Good to see the product as well, and get an overview of what the major